This is Amir Hamza along with my group mate Bakar Akhtar, and my project title is Small Wind Power Generation Unit for Domestic Consumer under the supervision of Engineer Shakil Ahmed Jiskani and co-supervisor Engineer Ghulam Akbar. So this is a presentation outline. First one is introduction, after that problem statement, then proposed solution, then literature review, then aims and objectives, methodology, wind assessment, calculations and dimensions, SolidWorks design, ANSYS simulation, results, conclusion, future recommendation, and then at last, references. We know wind turbines are devices which convert the wind energy into electrical energy. There are two types of wind turbines, horizontal axis wind turbines and vertical axis wind turbines. A vertical axis wind turbine has its axis perpendicular to the wind streamlines and vertical to the ground. According to Bill's limit, the efficiency is 49% for watts, and watts generally function better than hertz in turbulent and gusty wind, which is the main advantage of watts. The reason for this is mainly because of good efficient rotors and their advantage over the horizontal axis wind turbines, such as these are simple construction, extremely cost-effective, acceptance of wind flow from any direction without orientation, and watts are noiseless while operating. We are designing egg-beater Teres wind turbine type, and the Teres turbine is a lift type vertical axis wind turbine. It is normally built with 2 or 3 blades. It rotates much faster. The rotor can take wind from every direction. These are easily integrated into buildings. They have C-shaped blades and they require less starting torque. The problem statements: fossil fuels are depleting nowadays very fastly, and fossil fuels cause ecological hazards. We have to entertain domestic consumer. This is the main problem statement. Disadvantage of fossil fuels: they have limited supply. If they affect on human health, the fossil fuels are dangerous for the environment. So the proposed solution, that we have designed a wind turbine which perform its operation on low wind speeds according to NREL, National Research Energy Laboratory of USA, have estimated the potential in Pakistan is 50,000 megawatt from wind energy utilizing. And we know lengthening the blades of wind turbines, we can increase our output. So after that, we have literature review. We study different research papers. The first one is the first one title is Teres vertical axis wind turbine for power generation, assessment of a various watt configuration. In this research paper, they designed the different airfoils of the egg beater wind turbine and come to a conclusion that on the right configuration and position. After the first one research paper, the second one title is parametric study of hybrid simultaneous Teres turbine. In this paper, they uses the ANSYS software and designed the wind turbine by getting the best values according to the study of the pressure and velocity of wind. Also in this paper, it is mentioned that ratio of height and rotor diameter approximately equal to 1. In another research paper, which has the title An Aerodynamic Study on Flexed Blades for Watt Application. In this paper, the approach used is based on experimental and numerical work. At the end, they come to a conclusion by comparing the experimental and numerical study. This study suggests further optimization work in order to and a suitable flexure which can be used without a substantial effect on power performance. These are the aims and objectives of our project. The first ones are aims. to design an efficient mini vertical axis wind turbine for commercial usage, converting efficiently wind energy into electrical energy, designing prototype for domestic consumer. The objectives are designing of vertical axis equator wind turbine on SolidWorks, simulation of design on ANSYS Fluent software, then fabrication of equator wind turbine blades, assembling of equator wind turbine blades, electrical power output of a equator wind turbine. At last, comparative analysis of actual and simulation results. This is the methodology we have followed. First one is a literature review. After that, wind resource assessment, importing coordinates of NACA 0018 aerofoil in SolidWorks software. After that, ANSYS geometry, meshing and setup. Then simulation on ANSYS. After that, analysis of simulation results. Then selection for best material. After selecting the material, we have fabricate the prototype. So first one is wind resource assessment. We have done the wind resource assessment for the Dera Ismail Khan city in Pakistan. In Pakistan, we have get this data from the website of weather department. The data is for the 5 years from 2016 to 2021. The average wind speed is 4.5 meters per second for the DA Khan city. These are calculations and dimensions. Rotor height is 1.25 meter, rotor diameter is 1 meter, rotor radius is 0.5 meter, coefficient of performance is 0.4, wind speed is 4 meter per second and 5 meter per second, air density is 1.22 kg per meter cube, tip speed ratio is 6, number of blades are 2, area of the wind turbine is 1.25 meters square, power in wind at 4 meter per second is 20.67 watt, and at 5 meter per second is 69.76 watt. Output power at 4 meter per second is 8.26 watt, and at 5 meter per second is 27.97 watt. The RPM at 4 meter per second wind speed is 343.94, and at 5 meter per second is 515.92. Torque at 4 meter per second is 0.229 Newton meter, and at 5 meter per second wind speed is 0.514 Newton meter. Ratio of rotor diameter over rotor height is 0.8. Wind velocity at 10 meter height is 4.5 meter per second. These are the dimension of Teres wind turbine. Height is 1.25 meter, diameter is 1 meter, chord length, which is this 0.102 meter. This is the NACA 0018 aerofoil design, and these are the coordinates which we have taken from the website of NACA airfoil. After getting these coordinates, we have imported into the SolidWorks software. After importing the SolidWorks, in SolidWorks NACA 0018 coordinates, we have set the dimension of required wind turbine, and after setting the dimension, we have designed this one type of Teres wind turbine in SolidWorks. This is the ANSYS simulation. This is the first one, cylinder meshing, and the second one is stator meshing. After that, we have defined the inlet and outlet of air in ANSYS software. This is the velocity speed, and then this is the velocity contour, and this is one is pressure contour. Here we can see the velocity contour is shown, is defined here in the middle of the wind turbine, and at the upper and lower part the velocity wind speed is lower, and this one is the simulation field of the wind turbine. We can see the velocity contour where the wind hit the most are low. After the simulation video, here are the ANSYS calculations. We can see the area on inlet is 1.474 meters square, and at outlet 1.474 meters square, and at rotor 1.474 meters square. The torque is 1.5528 10 is power minus 6 Newton meter, and here is 0.63318 Newton meter at outlet, and at rotor 0.46713 Newton meter. The force on inlet 2078.09 Newton, and at outlet minus 1981.21 Newton, and at rotor 3.42479 Newton. This one is the hardware prototype. After fabrication, the hardware design looks like that. This is the front view. That one is a side view of the wind turbine. And these are the wind turbine blades view. This one, the hardware video. The wind turbine works at 4.5 meter per second wind speed. These are the results after operating of hardware at 4 meter per second wind speed. We have get the voltage 13.22, the current 0.613, and power 7.932 at RPM 340, and the load is DC fan motor 555. At 4.5 meter per second speed, voltage is 18.34, current 0.6140, and the power is 10.982. The RPM generated 505 at load DC fan motor 555. When the wind speed is 4.2, the voltage are generated 14.13, the current is 0.98, and power generated 13.847, RPM 423, and the load was DC 12 volt bulb. When the wind speed is 4.77, the voltage are generated 19, and current is 0.991, power is 18.829, and the RPM was 568.8, and the load was DC 12 volt bulb. This is the voltage at 4 meter per second. This is the voltage at 4.5 meter per second wind speed, and this is the RPM at 4.77 meter per second, and this is the RPM at 4.2 meter per second wind speed. This is the power wind speed graph, power versus wind speed graph. Here we can see the power at y-axis, and at x-axis the wind speed. So we can see at 4 meter per second wind speed, there is the power at 8, at 4.2, there is the power at 10 point, between the 10 and 12. Here is the power at 4.5, 14. This is the RPM versus wind speed graph. Here on y-axis RPM, and at x-axis wind speed. So at 4 There is the RPM between 300 and 400 and so on. So our conclusion of the project, the whole FIP project, we have concluded that wind energy is the best option by utilizing efficiently to overcome the issues related to the electricity. We can easily install the vertical axis wind turbine where the wind speed is not high. The advantage of the vertical axis wind turbine is that it can produce power generation at the low wind speed. For domestic consumer, vertical axis wind turbine is the good options. And these are the future recommendations. Design the hybrid wind turbine for resolving the issue of self-starting. Design the wind turbine using the carbon fiber material. Design the strong and lightweight shaft for wind turbine. Use the permanent magnet generator. Use this product for commercializing. This is the best product for commercializing. Future recommendation, these are the references which have taken the material and the references. Thank you so much for your time.